Hey everybody, it's Matt here with Kojo.io. So in this series, we're going to be talking about some really important CS foundational concepts. Things like binary, things like floating point numbers, things like what is a compiler, what is assembly. And the reason we're talking about it here is because in the other courses, like Swift Basics and how to build an Android app from scratch, we're going to be touching on those topics. We're going to be mentioning them, but we're not going to spend a lot of time in depth. So that's the purpose of this CS Foundational course. So what is computer programming? We're writing instructions that are understood by the computer. It's more complicated than that, but that's really the most simple definition. What I mean is, it is more than just writing the code, because day to day there's a whole lot of testing. You almost never get it right that first try, so you do a lot of debugging, which means finding out why your code isn't doing what you thought it was supposed to do. There's also a lot of maintaining code. So as you start coding for a long time, the code that you write today might exist in your code base for 6 months, a year, 2 years, 5 years, something like that, even longer. And so it's important to know how to integrate that code, the code that you wrote before, with the code that you're writing tomorrow. So again, what is computer programming? We're going to look at a couple of different languages. So the basic idea of what we're going to be writing is something like algebra. So we're going to have 4 values, 1, 2, 3, 4, and we want to set some fifth variable equal to the value a times b times the sum of c plus d. So the idea is the resulting e value is going to be 14. So this is so you may have heard that computers really only understand ones and zeros, which is absolutely true. Here is the binary. This is partial binary from a program that I wrote that does that math from the slide before. And so you'll see it is all just ones and zeros. I compiled it with the GNU compiler on Windows. It generated a .exe file, an executable file, and then this is the binary contents of that file. And it's actually only partial. This right here is that entire binary file. All right. So lots and lots of ones and zeros. This is what the computer understands. Luckily, nobody really writes in binary. Maybe in the early days of computing, that was how people had to input their instructions, but these days, nobody does that. One step above, I don't want to say more common, but one step above is something called assembly. This is kind of the first, this is the first human readable language. Obviously, it's much, much better than binary. These instructions have a direct translation to some binary values. So the instructions would be things like MOV is move, so we're kind of moving the value 1 into some address. You can kind of see, so I'm moving some values. There's my 1, 2, 3, and 4. You see that I'm doing some multiplication right here. You can see that I'm doing some adding and then another multiplication. So there's really a lot going on here. And luckily, these days, most people don't write in assembly either. Things like Game Boy, the original Game Boy was all written in assembly. I'm pretty sure Game Boy Advanced at that point had... Did Game Boy Advance have... Yeah, Game Boy Advance was all written in C. But Game Boy, at least Game Boy was its own assembly language. You'll notice this says Intel x86 assembly. That's because this is... like I said, the assembly instructions directly translate to some binary values. So you can't necessarily just take the assembly from one processor, like an Intel chip, or for iPhone, like the ARM A7 chip. You can't take those instructions and assume that they're going to work on some Android device. And so the problem with assembly is, well, that it's ugly. But also the problem with assembly is if you write it one time, it's not guaranteed to work on multiple devices. So people started inventing even higher level languages, things like C, C++. In this case, here's Java. You can see it's definitely more human readable. Even if you don't understand what a class is or what these curly braces are doing, you can at least see that I'm doing some more direct math. You can see I'm creating my A, B, C, and D variables with the values 1, 2, 3, 4. You can see I create an E variable and I do my multiplication. A times B times the sum of C plus D. So it is at least much, much more human readable. It's shorter to write, which is also really nice. Java was it's used widely, but it used to be the main language on Android. That actually changed just recently. The nice thing about Java or C++ or a lot of these high-level languages is it can be compiled, it can be turned from something that's more human readable into binary on multiple devices. And so the nice thing about doing something in one of these higher level languages is that you write it one time, you write the code one time, and it will work for multiple devices. Like I said, with assembly, it doesn't really work like that. It will only work on a specific chip. So like a specific, for example, Intel or AMD or the ARM A7, something like that. So here is that same program in Kotlin. Kotlin is now the main language of Android. It works really well with Java, but Google is really trying to push Kotlin moving forward. So you see it's still a lot shorter. You don't need that class definition. Even if you don't understand what fun means and what val means, you can still see it's much shorter. I don't need things like semicolons, but I'm still doing that human readable math. So obviously the Kotlin and the Java are much easier to understand. The assembly probably will run faster if you were to write it in just assembly, but it takes a whole lot longer to develop. Nobody really writes in binary, and actually very few people write in assembly. Like I said, people used to write it for like Game Boy. Sometimes, I'm sure some people still do, but sometimes game programmers might do it if they're really trying to make a section of their code go blazing fast. But in general, people avoid that. They write it in Java or Kotlin or whatever and use a tool called a compiler to convert from that high-level language into the lower-level languages like assembly or binary. So choosing that language is always a trade-off between speed of development versus speed of execution. A perfect example of this is on iOS. The original language of iOS was something called Objective-C, and these days they've moved away from that, and they're building stuff in Swift. From what I understand, I haven't actually done tests on it, but I've heard a lot of other devs talk about this. The code that you write in Objective-C is going to be faster than the code that you write in Swift. It's probably not a big deal actually for your app, but if you were counting the milliseconds, it would be faster. But I don't know if we'll ever actually look at Objective-C in these courses, but if you look at Objective-C, it's very verbose. It's a big, big language. A lot of people think it's an ugly language, whereas Swift is more of what they call an expressive language. The things you want to do take less code to do them, and that's a really important trade-off. Okay, so as we're learning about programming, like I said, computers really do only understand ones and zeros. These ones and zeros are called bits, which is really just short for binary digits. Bits are grouped into sections of 8 bits, and those are called bytes. Each byte has a unique address in memory. So that's really what RAM is, if you've heard about RAM. If not, it's not a big deal. So in order to store data, like my variables 1, 2, 3, and 4, in order to store those in the computer, we need 3 things. We need where to store it, what is the value, and what is the type. And so that's kind of where the int came from that you saw before. But in this course, we're going to talk about those last two. We're going to talk about what is the value, so how are those bits arranged in binary, and what is the type. So we're going to learn about different types throughout the different courses, but we're going to understand how to interpret those bits and what those bits mean on the binary side of things. And you also might be asking yourself, okay, so what is computer programming, but what does it take to become a programmer? And the way I think about it is anybody can do it, but it takes a constant willingness to learn and hopefully some curiosity. Hopefully you do really like what you're doing. It's important to be able to learn because, as I mentioned before, Java used to be the main language of Android, but now it's Kotlin. Objective-C used to be the main language of iOS, but now it's Swift. You can still get a job. Certain places like Facebook still write a lot of their code in Objective-C and in Java. Maybe they haven't switched over, but as time goes on, more and more jobs are going to be going to those that know Swift, that know Kotlin, that know these newer technologies, and that happens all the time. Because technology moves fast, we constantly need to be on the edge. We need to know the newest tools or the coolest tools. So it really is about a willingness to learn. So you have to dive in. Sometimes there isn't documentation, so you have to just jump in and get your hands dirty and start playing around with the code and figuring out how it works. So two really good books that I like on this topic. If you want to become a programmer, one is So Good They Can't Ignore You by Cal Newport. He talks about the craftsman mindset versus the passion mindset. So the passion mindset is kind of being excited, wanting to have that intrinsic feeling about this is what I was meant to do. And that is good. That will get you to a certain distance, but there are going to be days where learning to program is difficult. It feels like a slog, right? You're going to run into some bugs that maybe you just don't know how to solve. So the craftsman mindset is instead taking that shift of being happy or feeling like you were meant to do this and thinking, how can I get better? So focus on getting better. Don't focus on what you don't know. Don't focus on the fact that some days are going to be difficult. Focus on how can I get better, right? And in The War of Art, Stephen Pressfield, he kind of talks about this a little bit as well. And he actually has a book also called Turning Pro. And he says the professional is somebody who gets up and he's a writer. So he says the professional is somebody who gets up and writes every single day. Doesn't matter how they're feeling. There is no writer's block. You get up and you do the work. And yeah, really, that's exactly how I feel as well. There's been lots of bugs that even now, I'll run into bugs and I think, man, this is going to be difficult to solve. Sometimes I even say, I don't know if I can solve this. This is difficult. But I just put in the time, I do my research, and so far I keep solving them. I'm getting better, and that's really the goal here. So yeah, throughout the rest of this course, we're going to be talking about different things like binary and compilers. It's not stuff that you necessarily need every day, but it's good to have that foundational knowledge. So I'll see you in the next video.